So I welcome you all to Vinchemy's online classes. So the chapter which we are going to do first is acid bases and salts. This is a common chapter of chemistry in class 7. So I'm basically going to touch up on the basic important things of this chapter. So with that, let me begin. So first I'm going to talk about acids. So basically we see many substances in our day-to-day life. Like if I go to the kitchen, I see a lemon kept there. Then below that, I see some vinegar kept there, as well as I see water, as well as I see some baking soda. And when I get up in the morning, what do? I go and brush my teeth. So there I use toothpaste. And then I go and bathe, right? There I use soap. And let's say your clothes get dirty. Then what do? You wash it with some detergent. And what do you do to the dishes which you eat? You again wash it with some liquid dishwashing liquids, right? So we use many substances in day-to-day life. But if you see many substances which you taste, some of them are sour and some are bitter, right? Like for example, I can say the sour substances are in this list. The sour substances are lemon, vinegar, right? Lemon, vinegar, tamarind, all these are sour. Whereas there are some substances which are bitter also, like baking soda, toothpaste. Toothpaste, if you have tasted, you'll see that it's bitter. Soap, just a minute. So there are some substances which are bitter, like baking soda, toothpaste, if you tasted, it will be bitter. Soap, I don't know if you have tasted. If you tasted soap water, that will also be bitter. And yeah, detergents also will be bitter, but we don't know detergents, soap are bitter. So let's just leave that. But if you tasted baking soda or soda, the one which you put in that cakes, etc., to make it fluffy, that one will be bitter. Toothpaste will be bitter. So this is bitter. Water is tasteless. So we can water is tasteless. So it's neither sour nor bitter. So the substances that are sour, we classify it generally as acids. Generally, we say substances that are sour are acids, and substances which are bitter are bases. So I'll tell you a trick to remember this. You can just remember like BB, right? So bases are bitter and acids are sour, right? So lemon, vinegar, tamarind, and yeah, all these are sour, so they're all acids. They all contain acids. Okay. But can we taste all the substances we see in nature? No, right? Because some substances are toxic, meaning they are harmful to human beings. They are harmful to us. We can't just go and taste detergent, or we can't just go and taste something kept in the lab. We can't just go and taste some toilet cleaner, let's say. So then how do we classify substances as acids and bases generally? This is one classification by tasting and saying whether it's sour or bitter. But practically, we can't taste all the substances found in nature. Hence, there's another method to classify acids and bases. And for that, we use something known as an indicator. So the name itself suggests us what an indicator is. So it just indicates us whether a given substance given to us is an acid or a base, isn't it? So that's what an indicator basically does. It just classifies a given substance as acid or base. So it just classifies an unknown substance as acid or base. So indicators are two types, natural indicators and synthetic or man-made indicators. Synthetic or man-made, synthetic in the sense man-made indicators. So before I go and discuss about these indicators, I would just like to say that there are two types in acids also, that is natural and man-made. So all these acids which are contained here, okay, all these comes under natural, and the ones which make in the lab comes under man-made. Okay. So I'll just like to tell you what are the acids present in these things. So in lemon, the acid present is called citric acid. You would have heard people saying lemon, amla, orange, etc., citrus fruits. So the acid present in lemon is called citric acid, right? And the acid present in vinegar is called acetic acid. The acid present in tamarind is called tartaric acid. And if you see even one more substance which we use in a day-to-day food is sour, and that is curd, right? So even curd has an acid, and that is called lactic acid. Okay. So all these acids and the source is given in your textbook. You can just go through that. So all these acids, tartaric, citric, acetic, lactic, common, and natural, and all acids like, which you make in the lab, like hydrochloric acid, sulfuric acid, which are actually dangerous, right? You would have seen movies, they throw acids on people's faces, right? Those acids are man-made. Those acids are generally corrosive, meaning harmful to our skin, right? So in indicators, again, we have natural and man-made. Natural is from nature, mostly flowers and plants. Synthetic is what we make, right? So under natural indicators, your turmeric, right? So that is an indicator. It can tell whether a given substance is acid or base. So turmeric is a natural indicator. And mostly there's turmeric, and one more thing is China rose. And under synthetic or man-made indicators, even litmus is a natural indicator because it comes from a plant called lichens. So even that's a natural indicator. Under synthetic or man-made indicators, you have something known as phenolphthalein, methyl orange, etc. So we discussed all these in detail now. Okay, first I'll talk about turmeric. Okay, so I told you what an indicator is. It tells us whether a given substance is acid or a base. So basically, I have an acid here. Okay, let's say I have some acid here. I have a base here and have turmeric solution here. One more thing is this acid and base should be in the solution form. If it's something like a powder, you have to mix it with water and make it to a solution form. Okay. So I have turmeric here. Okay. So I'm taking few drops of this turmeric solution, putting in this acid, and taking few drops of turmeric and putting in this base. So you all know what color turmeric powder is, right? If you don't know, have it here in the sea. This is turmeric. You all see. Just give me a minute. Yeah. Okay. So basically, it's yellow color, right? Yeah. So So what they say is if you add turmeric to an acid, you'll have no change. So turmeric is yellow color, right? Turmeric is yellow color. So if you add the acid, there will be no change. Whatever color the acid is, it will be the same color. But if you add to a base, the solution turns red. Solution turns red, whereas here no change. Here there is no change to add turmeric. Whereas when you add a turmeric solution to base, the solution turns red. So isn't this a good indicator then? It tells us with the color change, whether it's an acid or base. Indicators can tell us whether a given substance acid or base, either based on color change or based on smell change. Okay. So basically, the indicators which are there in your textbook are based on color change. Okay. So show change in color in acid and base. So when I put turmeric in acid, there's no change in the color. When I put it to a base, it gives me a yellow color. So no need to taste acid and bases then. I can use these indicators and actually test. So I'll just demonstrate that to you, right? Okay. So you can just see I have turmeric here, right? So you can just see I have turmeric powder. Just mixing it. Just give me that. Yeah, so I'm just mixing this. Okay. And I have two unknown solutions. I don't know what these two solutions are. Okay. Let me say this one is okay, this one is A and this one let it be B. Okay. This one is A, okay, and this one is B. Okay? This one is my A and this one is my B. So I'll just put this turmeric solution in both the solutions. You identify and tell me which is acid and which is base, right? So I'm just putting in this one first. Okay, so you can see it says yellow, right? And I'm putting in this one. Okay. So I put in both A and B, so you can see. Okay, so you can see in this case, both are yellow, right? Both are yellow. So both can be acids. Both can be acids. That's what we conclude, right? Because there's no color change here. You can see this is just yellow. And this also just yellow. There's no color change. So I can now conclude that both are acids, right? Now I'm going to change the solution, bring something else. And you tell me whether it's an acid or base. Okay? So, yeah, give me a minute. So I have got one more solution here. So again, going to try adding turmeric to this. Okay, I think something's wrong. I'm not getting the desired results. Anyways, yeah, so you people can later try taking some turmeric solution in a glass, okay, and just try it with different solutions in your house. Like you can try with soap water, toothpaste, baking soda solution will work very good. Some soap powder and vinegar, acetic acid. You can try with many things, okay, and check out whether they are acids or bases. That's the best acids or bases. Okay, so now I'll just get back to my room. So this is about turmeric. Okay. But if you see here, we can't say this is a proper indicator or good indicator. The reason, okay, the reason being this turmeric, right? If I add to acid, it will show no change. Even if it's a neutral substance, neutral meaning neither acid nor basic, like pure water. Pure water is not acidic, not basic. It's neither acidic nor basic. Those substances are called neutral substances, right? So for those substances also, it will show no change in color. So if it's showing red, you can say yes, it's a base. But if it's no change in the color, you cannot say it's an acid, right? You can just classify it as either an acid or a neutral substance. Hence, this is not a good indicator. Hence, I'm going to take another indicator. This is called pH indicator. Okay, we can see it's called a pH indicator. So just see the scale. Don't see all these numbers, etc. Okay, don't see these numbers. Just see the colors. All these colors, right, are called acidic. And if these colors comes, it's called alkaline or basic. Alkaline means basic. Okay, and with this, it's called neutral. Neutral means neither acidic nor basic. It's not acidic, not basic. That's what it means. Okay, not acidic and not basic, right? Okay. So, okay. So if you see here, I have something in my hand. This is called a universal indicator. Okay, so you can see I've got another solution here, right? So again, a color solution. But let's see. Yeah. So there's color change. I don't know if you can see it. I'll show you, right? So you can see your small color change, right? On the top, can you see there's a color change? Yeah. It's slightly let's see what color it is, but you see this solution is red color. Okay, we see this solution, it's red color. Okay, this solution is red color. You can see. I'll just show you the color change. See, it's a red color, right? And it's flowing, falling, and this has become green. I'll just show you it. Okay, so this green color is just because of this indicator. So this aside and just see it's red color. And it's falling, right? When it falls, you can see it become green color, right? Yeah. So let's just see what's happening. So you can see it's changing to green, right? It's taking some time because there's some indicator already on the top, right? So yeah. So yeah, I'm not doing much. demonstrations on this because this is not in your syllabus. But if you find it interesting, if you wanted me to try various solutions, do let me know in the comments, and I will do it in the for the next videos, right? So you can also try various things like this and just see the results. Okay, if you just have turmeric solution, that's more than enough. Turmeric works as a good indicator. Even red cabbage, okay? Even red cabbage is a good indicator. So you can just beetroot, all these are good indicators. You can just try with these solutions as indicators. So in this class so far, I've discussed what is acid, what is bases, types of acids. Then I discussed about indicators. Then I started with turmeric being an indicator. And now I'm going to go and discuss about another natural indicator, that's your China rose, right? So just see this, okay? China rose is a flower, okay? China rose is a flower. And if you just, take the petals and put it in a mortar or a mixie and grind it with some water into paste, that color will be pink. The indicator's color will be pink. And if you put it to an acid, the solution changes into an orange color, okay? The solution changes to an orange color. And if you put it a base, it changes to a green color. So you just need to remember these color changes. Okay, later I give you like a table, okay? All the indicators and the color changes, you just need to remember. So that's about China rose being an indicator, right? So, so we studied how turmeric acts as an indicator, how China grass acts as an indicator, right? Now, now I'm going to talk about litmus being an indicator. Litmus, okay? Litmus is a solution taken from a plant called lichens, and this litmus solution generally purple color, okay? This litmus solution generally purple color. This litmus solution, if you put in acid, right? It changes to red color. And if you put the base, right? It changes into. So, if you see, the litmus solution is generally purple in color, right? It turns it turns acid to red color and base to blue color. Okay, so it changes base to blue color and acid to red color. This litmus is also available in the form of papers. So they take a paper, filter paper, and dip it in litmus solution and sell it as red litmus papers and blue litmus papers. So far we have studied the three main indicators. That is your turmeric, and then China grass, and then litmus. There's also one more indicator mentioned in your textbook, that is called phenolphthalein. Phenolphthalein. Okay, so this is also a very important indicator. Okay, this phenolphthalein, okay, it changes acid to colorless. Whatever the solution, or whatever the color of acid, or whatever the color of the indicator, okay, phenolphthalein, okay, changes into colors in acid solution, and in a basic solution, it changes it changes into pink color. Okay, pale pink color. Okay, so that's about this indicator called phenolphthalein. So also one more thing, okay, you can actually play with indicators. Like if you have turmeric, you can actually play with it. Like you can send secret messages with turmeric. Okay, I'll tell you how. I don't know if you've seen these in YouTube videos, but it's an experiment where they take a paper, okay? They take a paper and fully fill it with this turmeric paste. Okay, they dip a brush in turmeric water and fully paint it with turmeric paste. Then you know what they take? What do you do? They will take a glass with some basic solution, let's say soap, water, or something, and dip a cotton swab, or some brush inside it, and then they write some message here. Okay, so that appears in red color. Or you can take lime water, okay? You can take lime water and maybe write something here. And if you dip it in soap solution and just wipe it over the paper, the message will appear in red color. So you can send secret messages. And even if you have observed, okay, if you have some curry spilt on your, dress, some white dress, generally curries like turmeric powder, isn't it? So when you dip it in some soap solution, it changes it changes to red. Same reason. Because soap solution is basic, so it changes that turmeric into red color. So yeah. Okay, so the last bit of this small lesson is a topic called neutralization. Neutralization. So if you just see in the experiences I did, okay, I was adding indicator and it was showing color change, color change, color change for every drop. But after one particular drop, it stopped showing color change and let's say it became saturated. That's the point when you say it has been neutralized. So the word neutralized meaning the amount of acids consumed, okay? The amount of acids consumed is equal to the amount of bases consumed, and there's no more acids or bases to react and show color change. That point is called neutralization point. Okay. So at the point of neutralization, the definition of neutralization is the base reacts to give salt and water, and this process is called neutralization. So don't tell me, so lemon has citric acid. Lemon has citric acid. If I treat it soap solution, okay, will I get something? I will say the answer is no, because citric acid is a very, very weak acid. Soap solution also very, very, very weak uh, base. Then it won't react. If both are weak, okay, then the team, both are weak, then the team won't win. It will lose. At least one should be strong, isn't it? At least A should be strong, or B should be strong, or both should be strong. Then only you can win. Then only you can react. So at least an acid or a base or both should be strong for neutralization to occur. So if you've heard of hydrochloric acid, HCl, okay, that can be used. So basically, I'm not going into any big equations at all. Just remember that when an acid and a base reacts, okay, it gives you a salt and water, and this process is called neutralization. Just you're becoming neutral, right? Two opposite armies, okay? I don't even like you. Then they fight, and then they become, brother and sister. They're fighting, and finally, what they become? Yeah, they again become friends, isn't it? So that's how neutralization basically works. Okay, so now let's see some day-to-day applications of neutralization. Sorry. Yeah, day-to-day examples of neutralization. First one is indigestion or acidity, I can say. Okay. So you're seeing your dad or some uncle or somebody, they go to office, they work for many hours, they don't eat properly, and they come home very late, let's say at 3 p.m. and then only eat their lunch. And breakfast, they eat very early, so there's a huge gap breakfast and lunch. So then their stomach starts getting irritated and getting itchy, and they find difficulty in eating all this, right? So that's all because of a problem called acidity. So acidity means your stomach, right? Your stomach that has an acid, that a powerful, strong acid, hydrochloric acid. Okay, it's a powerful, strong acid. It's not like a lemon juice. It's a powerful, strong acid. So if why is no question may arise in our mind. Why should a strong acid be present in our stomach, right? Our stomach is our organ, and why should a strong hydrochloric acid be present in our stomach? It's a good question. This its uses is basically to kill germs. Okay, to kill germs in our stomach. That's what it does. And so what happens is when you eat the food, okay, this hydrochloric acid also helps in digesting, right? It breaks the food into small, small pieces. That's also one of the role of hydrochloric acid. So when you eat a lot, okay, or when you eat very less, or when you eat after a huge gap, what happens is this hydrochloric acid starts secreting in your stomach. Then what happens is, let's say your stomach is this, right? So what happens is your hydrochloric acid will start secreting, right? So it will start, killing or what do you say, will start, irritating, okay, or tearing the tissues of your stomach. That's why your stomach starts itching, your stomach starts irritating, right? It starts, degrading the stomach because there's no food for it to act upon. So it starts acting on the stomach itself. So it starts degrading the stomach. So then what can we do is we should take a base. As I told you, that's what's called neutralization. When a strong acid is acting, you have to put its opponent, to put its enemy, it's a base. So if this acid, it's acting, it's destroying something, and you want to reduce it, you have to put a base. Base is that it's destroying something, you have to put an acid. That's called neutralization. Okay? So when an acid and base reacts, their activity, their impact gets reduced, and they both become normal sadhu people. That's what they do. So acid alone is powerful, base is also powerful, but they both react, they lose their energy and become normal. So for that, we have to put a base, but that's also one more reason. Base shouldn't go and do some effect in your stomach. Base should be a very strong base so that it, does some harm to your stomach again. It shouldn't alleviate the problems, reduce the problems. Base should be strong, sorry, weak base, right? So for generally, people take Gelusil when they have acid, Gelusil or Eno, right? So all these has some base. So generally, earlier people used to take a base called milk of magnesia. Okay, It's not milk, it's a base called milk of magnesium, and people take during this problem of acidity. And that has a base of magnesium hydroxide. Okay, you don't remember the formula at all. Just remember it as magnesium hydroxide. Generally, hydroxides are bases. Okay, generally hydroxides, okay, will be bases. Okay. So yeah, milk of magnesia is a base which people take for this problem of acidity. Okay, next one. Have you ever had an ant sting or honeybee sting? Right? Honeybee sting also acidic. So you may ask, the ant only bites, no, does it sting? There is a particular type of ants, okay, a big black or red ant, which actually has a sting, and yes, it stings people. When it stings, it will become itchy over that area. The ant stings is causes us itching, right? This is because of an acid. So this ant injects an acid called as formic acid or methanoic acid, which goes into our skin, and you all know acid are corrosive, hence it causes some itching. So again, the remedy is by neutralization to the acid. So to neutralize this, I have to add a base. So for that, I can add some weak base, like something like again baking soda or some weak base you can apply on the stung area. The third example for neutralization in everyday life is agriculture, I would say. So if a soil is very acidic, okay, if a soil is acidic or basic, a plant can't grow properly in it. It should be neutral. So for that, they take a sample of soil and test it some integrate and see whether it's an acid or base. So if it's acidic, they have some weak base, and basic they add compost. So compost is a fertilizer which supplies acids to it and neutralizes the alkaline nature. So these are some common examples of neutralization in everyday life, right? There are also many other examples given in your textbook. Yeah, so most of it I told you is this is just about factory base. So the base of the factories, right? They have acids. So if they're plunged into the water bodies, they kill the fish and other living organisms present in the water bodies. So for that, we first neutralize it by adding some basic substance. So if you see here, right? So if you see this question, the first question says state differences between acids and bases. So acids are sour, bases are bitter. This is one common example I can say, one difference I can say. And one more difference, actually, I forgot to say, acids. Okay, acids are, bases are soapy to touch. Bases are soapy to touch. So yeah, that's about it. And you can even say something related to indicator, like acids change, let's say, litmus to blue, and acids change litmus to red, and bases change litmus solution to blue. So that can also be a difference. Ammonia is found in many household products such as window cleaners. It turns red litmus blue. So which turns red litmus blue? Bases. So its nature is basic, because only bases turn litmus to blue. Okay. So just remember, like, the acids turn litmus to red. Which litmus to red? Blue litmus to red. Bases turn litmus to blue. Which litmus to blue? Red litmus to blue. So here it turns blue litmus to red. Okay. So it turns to blue, turns litmus into blue. Don't worry about this color. Just remember, like, litmus to blue. Because it's basic. Okay, so the window cleaners, it's basic. Okay. Name the source from which litmus solution is obtained. I told you many times. It's obtained from a plant called lichens. Use of this solution acts as an indicator, right? Yes. Distilled or acidic, basic, neutral, it is neutral. How would you verify it? By using litmus solution. Okay. Don't use turmeric. Use some other indicator like litmus. It won't change. Sorry. So it won't show any change in color. Hence, you can say it is neutral, right? So describe the process of neutralization with the help of an example. You just have to describe the process of neutralization in a textbook. Like you say, a salt and a base reacts to give salt and water with the evolution of some heat. It's an exothermic process. It gives out heat. So that's called neutralization. You can say any one of these examples which I discussed, like you can say about acidity, you can say about agriculture, you can say any one example. True or false? Nitric acid turns red into blue. So it's acid. So acid turns litmus into red. So this is false. Sodium hydroxide, I told you if it is hydroxide, it's a base. Sodium hydroxide turns litmus into blue. So this is again false. Sodium hydroxide and hydrochloric acid is an acid. Hydroxide is a base. So they neutralize each other and form salt and water. It's true. Indicates the substance shows different colors, acidic and basic. It's again true. Tooth decay is caused by the presence of base. This I forgot to tell you. Tooth decay, okay? Why is it caused? Toothpaste is a basic. So tooth decay is actually caused due to the presence of acid. When you don't eat or when you don't, your mouth is left without washing for a long time, then acids get secreted. Okay, the bacteria acts and acid gets secreted. And what does this acid do? That's what tooth decay is caused. So to neutralize that, we put toothpaste and brush our teeth, right? Which has base. Toothpaste has base. Tooth decay is caused due to acid. So this is false. Let me just continue. Told you has few bottles of soft drink in the restaurant. Unfortunately, these are not labeled. You have to serve the drinks on the demand of customers. One customer wants acidic, another wants basic, and third was neutral. So to again, you can use some indicator for these things. Whenever there's something called neutral mentioned, do not use turmeric. Okay, don't use turmeric. It's not a good indicator. Go with some other indicator like litmus. Okay, so just put litmus to three solutions. So I have three things. I'm putting litmus to three things. In one of the solutions, the litmus turns into red, and such a solution is acidic. Okay, in one solution, will turn blue. In one session turn blue, and that is base. In one session show no change in color, it purple. So it remain purple. Okay, no change, and that is neutral. So that's how you identify. Explain why an antacid is taken in supplemental acidity. I already explained to you, right? Yeah, to neutralize your acid. Calamine solution is basic. That's also applied on the skin or antibiotics. All these is given in your textbook, so it's not tough. Okay. Three liquids are given to you. One is this, another is this, third sugar. How will you identify them? You can only use turmeric indicator. Now there's a problem. Now it's a problem. Okay. So I'll put turmeric to all these things. Wherever this hydroxy is the basic, so turmeric changes base to red. So here it changes into red. So now I can surely say this is a base. Since it's a red, I can surely say it's a base. Now to the other two, it will still be red, right? Now I can't surely say whether this is an acid or a neutral substance, right? We can't surely say whether it's acid or a neutral substance. We can just say it's not a base. Blue litmus dipped in the solution remains blue. What's the nature of the solution? So blue litmus, okay. As I told you, acid changes litmus to red, bases change litmus to blue. Okay, so which litmus to blue? Red litmus to blue, obviously. Here, blue litmus to red. So blue litmus different solutions. It's remaining blue. It's remaining blue. Okay, so blue litmus to red. So it's remaining blue. It's not changing to red. But it's not an acid, it's a base. It's a base. So that's about it. So do comment down which chapter you want me to take next, right? And also do comment other video ideas. Okay. So thanks for watching and bye.